Hello students, in this lecture we shall discuss the electric braking of DC motors. As the name suggests, it is the braking method where we somehow reverse the torque produced by the motor electric, and that method is known as electric braking. Other method is the mechanical braking, where we apply some pressure on the shaft of the motor, and that causes the motor to stop, and the energy stored in the system will be dissipated in the form of heat across the brake shoes. So that method is uneconomical. The energy stored will be wasted, and moreover it will produce more noise. So we want to have a good braking system where the energy stored in the system is utilized and there is no mechanical friction, etc. So this method is known as electric braking. We reverse the torque so that the torque which was running the motor now acts against the motor speed and stops the motor. So what is the need of braking? We have to stop the motor quickly, otherwise the motor will take longer time to stop. For example, you are having some vehicle and you have to stop the motor quickly, or you have to reduce the speed quickly, then you have to apply the brakes. And moreover, sometimes we are having some active load such that lift or hoist or some train is moving down the slope. Because of gravitational force or torque, the motor speed may become very high, so there also we require some braking. So there are broadly three methods of electric braking: regenerative braking, dynamic braking, or we also call it rheostatic braking, and the third is plugging. In the first method, regenerative braking, as the name suggests, the mechanical energy stored is regenerated and it is sent back to the electrical source. So the energy is not wasted, it is sent back to the source. In the dynamic braking or rheostatic braking, the energy is stored in the mechanical system, the motor is running, it has some kinetic energy, that energy is dissipated in some resistance connected across armature. And the third method is plugging, that is you can say reverse polarity braking, where we shall interchange the terminals of the supply voltage to cause the braking. So today we shall, in this lecture I will only discuss the regenerative braking. In the next part I will discuss the dynamic braking and plugging. So now let us recall what is the motoring operation, what is the braking operation of a DC motor. I have drawn here the circuits for DC motor. So this is the back EMF, armature resistance. I have not shown the symbol of armature here. I have just shown the equivalent circuit. So for motoring operation, the voltage has to be more than the back EMF. So that will cause the current to flow in the positive direction. So current will be equal to V minus E upon RA. So energy will be coming out from this source and it will be stored in the mechanical system of the motor. It is converted into mechanical energy. E into IA is the power which is converted into mechanical form. So this is the motoring operation, normal motoring operation. So V will be greater than E. And if we want to reverse the torque, and the torque depends on IA. Torque, if you remember, torque is equal to some constant times IA. I am assuming that the flux is constant. So torque is equal to K times IA. So if you want to reverse the torque, what you have to do? We have to reverse the direction of current. If current reverses, torque will also reverse. So in the motoring operation, what happens? Torque is positive. So the torque is in this direction, the motor will also run in the same direction. So motor speed and torque will be in the same direction. That is, the motor torque causes the speed of the motor. In braking operation, what you can do, you have to reverse the direction of flow of current, because torque depends on current. As the current reverses, torque will also reverse. So the motor running in the same direction, and you reverse that flow of current, then what will happen? Torque will reverse. Now this torque will oppose the motor speed, so that will be called a braking torque. So if you are somehow you are able to do this, then the current will reverse, torque will reverse, and the torque will act against the speed, and the motor speed will gradually reduce. So the current that the motor will draw will be equal to E minus V upon Ra. E is greater than V. So somehow this situation has to occur that E should be greater than V. So this will cause the braking operation. So this is the case. So how we can now you can see here in the braking operation, energy current is leaving this terminal. So this means that the mechanical energy is the output energy. So it is actually energy is being supplied by the mechanical system, and this source, power source, is actually absorbing the energy. So for this type of braking, the source must have capability of absorbing the power. It must be having some supply system where other loads are connected, so that the energy released by this system is absorbed somewhere else. So this is basic condition. If the source doesn't have capability of absorbing the power, then this method of braking cannot be used. So now what are the possible ways in which we can achieve regenerative braking? And this is most efficient way of braking, because energy is reversed or returned back to the source and utilized somewhere else. So the possible ways of braking is regenerative braking is, number one is there is some active load connected to the motor, and that active load drives the motor such that the speed goes beyond the no load speed, and as speed increases, this you can say that this E is proportional to speed of the motor. So if the speed increases by some other means, by some active load, then E may become more than V, and motor automatically goes into the braking operation. Suppose we are having here, this is the characteristic of the motor. I have drawn it for the whole range, whether current is positive or negative. So for a particular voltage, so suppose this is the rated voltage, and the motor is running somewhere here. But suddenly, for example, you are having a train or some locomotive or some vehicle. So suddenly it goes to some slope, and because of that gravitational force, the speed of the motor starts increasing. So operating point will move like this, and finally when the speed becomes more than the no load speed, we reach somewhere here. So motor goes into braking operation. So as soon as it happens, the current will reverse, and the same motor which was running as a motor, now it starts working as a generator, and the energy stored in the system will be returned back to the source. So this is one way where regenerative braking is possible. Now the second way, where we want to stop the motor, in that case we have to reduce the voltage such that V becomes less than E. So we must have some variable supply voltage that can be varied. So this voltage needs to be varied. So suppose you are having operating at this point, full load operating point. This is full load current, and this is full load current in the negative direction. It is twice the full load current in the negative direction, and you remember that current should not exceed beyond the permissible current for that motor. Normally it is twice the full load current. So what happens is that you are operating here, you want to stop the motor. For example, you want to stop the motor quickly. So what you can do here, you reduce the voltage such that current becomes negative, and it becomes negative, and you want to generate maximum torque in the reverse direction. So you can go for the current which is permissible for the motor, say twice the full load current. So you reduce the voltage such that characteristic shifts downward, as we discussed in the previous lecture, by reducing the voltage, the characteristic shifts downwards parallel to itself. So, and the speed, as you remember that it is a mechanical system and the motor has a high mechanical time constant, electrical time constant is smaller. So as soon as we reduce the voltage, current will change almost instantaneously in a fraction of a second, and torque will reverse, but the motor speed will not change instantaneously, it will take some time. So this happens as soon as you reduce the voltage, the current will shift to this value, becomes negative, and we have this operating point. So now the current is negative, torque is reversed. Because of this negative torque, the torque is opposing the motor speed, so speed of the motor will start decreasing. So you want to quickly stop the motor. If you leave the voltage to this level, then motor speed will decrease and finally it will settle down to again to this operating point. So we don't want this. We want to stop the motor quickly. So as soon as the current reduces slightly, say it becomes a full load current, you again reduce the voltage such that, so after reaching here, so from this point, operating point, you have reached this operating point, and like this, and when we have reached here, again we have reduced the voltage. Suppose it is somewhere here, again the motor speed will decrease, and we have reached here, again you reduce the voltage to V2, then to V3. So again I will reach this point, again the motor speed will decrease, again reduce the voltage, and this process will continue till the motor comes to steady state. So you have to gradually reduce the voltage, keeping the current between, say, twice full load current and full load current. In between this range, you have to gradually reduce the voltage, and finally the motor will come to steady state. In this whole procedure, the torque is negative and E is greater than V. Energy is stored in the mechanical system, the kinetic energy is stored in the mechanical system of the motor, is converted into electrical energy and absorbed by this source. So this is what is known as regenerative braking. So this is most efficient way of braking because energy is not wasted anywhere, it is absorbed by the source. The third way of braking is using step up chopper. That is, we have the source voltage, which is a constant voltage source, and this is the motor. In normal operation, V will be greater than E, and you want to return this energy from, we want to flow of energy from this low voltage source to a high voltage source. Then in between you can connect what is known as step up chopper. So step up chopper will facilitate the flow of energy from low voltage DC source back EMF to high voltage supply source. So this is possible. We shall discuss this in detail when we shall discuss the chopper controlled DC drives. So this is what is known as the regenerative braking of DC motor. Now one thing you must note that this braking method. Now one more thing, you have to take care that voltage is not reduced to a larger step, otherwise the current may become very high. So this care has to be taken. While reducing the voltage, it is to be done gradually so that current does not exceed beyond the permissible current for the motor. Otherwise, it will cause commutation problem. It will cause sparking of the brushes, and that will reduce the life of the motor. And one thing you can see that I have discussed here the shunt motor or separately sighted DC motor, but this is not possible for series motor. Why? You have to think over it. That this method of braking cannot be implemented for a series motor. So what is the reason? You have to think yourself, and I can ask this question to you in YOC or examination. So that is all for today. Thank you.